So for section 2, we're going to be talking more about those quadratic functions. Remember I said in section 1 that we're going to be spending a lot of time working with this graph of these quadratic functions. But what we're going to look at today is specifically when it's in what's called standard form. We saw a little bit of that yesterday with those first examples that we did where we had to graph the equation using a table. All of those equations were considered to be in standard form because they had your x squared, your x, and then your number at the end. And so I kind of went over this with you guys yesterday, but all of those graphs are in that form ax squared plus bx plus c, where a, b, and c are just numbers. And we used those yesterday when we were trying to find like the vertex of something. We used that b and the a. So when we're looking at the quadratic equation, remember yesterday I said that all of your quadratic equations are like curved V shapes. The technical name for that is a parabola. So the name of a quadratic graph is called a parabola. So if you hear me say that, I'm talking about a graph of a quadratic function. We talked about the negative b over 2a yesterday, but that's also known as what's called the axis of symmetry. So when we found that point, that vertex, I told you guys that that was in the middle of the graph. That's where the graph started. And I said that the points on the other side of the graph reflect each other. They're the same distance away from that like imaginary line that I drew into the graph. Well, that imaginary line is called that axis of symmetry. Symmetry means that it should be equal on both sides. So when I find the vertex, there's like this imaginary line that's going through that point, and that's the middle of the graph. And so points on the left and points on the right are symmetric to that imaginary line. We also have something called the y-intercept. Y-intercepts are where points cross the y-axis, which is the axis that goes up and down. In order to find the y-intercept on a quadratic graph, you just have to plug in zeros for your x's, or the easy way is to just look at that c term, that very final letter, which we didn't do a lot with c yesterday, but we're going to be talking a little bit more about it today. Because if you know what the y-intercept is, you can also graph that point and then figure out where's that line of symmetry and just reflect it over on the other side. So we did this yesterday with that negative b over 2a, but that was the x-coordinate of the vertex. So I told you guys when you were doing your charts that that went in the middle because that was your x value of that starting point of the graph. So that's called that vertex point, and it's technically the x-coordinate. So there's a picture here in your guys' packet that kind of talks about those things I just went over. Y-intercept is that c that you can see that's on that y-axis. The vertex is right there in the middle of the graph. That red dashed line, that's acting as that axis of symmetry, so that's cutting that graph in half. Then they show over on the other side the reflection of the y-intercept, because you could figure out how far away it is from that red line and just push it over the same distance to reflect it there. Some other things that we can look at, and we saw a little bit of this yesterday as well, is when a graph opens up or if it opens down. And you guys noticed yesterday when our graph opened down, it's because there was that negative sign in front of the x squared term. So it said negative x squared, or it could even say like negative 3x squared. The second that that first number becomes negative, it's going to flip the graph upside down. So when we talk about maximums and minimum points up here, this minimum point here, that's like the lowest point that you're going to find on the graph. Okay, so I talk a lot about like, that's like a valley. So you're at the lowest point of the graph. If the graph has a maximum, so it's at the very tip top of that graph there, that's like you're up on a hill. You're at the very, very highest point. You can't go any higher, so you're at the max height there. If your graph opens up, that means that that first a term, like that x squared term, is positive, then you're going to have a minimum, because you're going to have a low point. And if that top point is negative, like your x squared is negative, it opens down, then you're going to have a maximum point. Okay? So we're going to look at a couple of those things for these examples. If you guys want to turn your page over. So they're going to give us a function, and what we need to do is describe some of this information. Describe how it opens, what's the axis of symmetry, what's the vertex, what's the y-intercept, and then we're going to graph it. So this one says x squared minus 1. If we look at the x squared term, it's positive because there's no negative sitting in front. That means that it's going to open up. Okay, so when it says opens, I would say up. It opens up. For the axis of symmetry then, we do that negative b over 2a again. That's why I said in section 1 you're going to use that equation a lot, so it's best just to store it away in your brain somewhere. So our b term would be what's in front of the x term. Since there is no x term, because it goes straight from x squared to a negative 1, that means that your b term is 0. It's not there, so it's a 0. Can you guys tell me what a would be? What number is in front of x squared? 1. So we're going to have negative 0 over 2 times 1, which it doesn't even matter what that ends up being because 0 divided by anything is 0. This is going to equal 0. So to find our vertex, we have that x equals 0. What we need to find is y. So this is what you guys did yesterday with those tables. You would plug in this point for your x's. So coming back up here to the equation, we're going to do 0 squared minus 1. That's going to give us our y coordinate. So you're going to have 0 minus 1, which is negative 1. So writing these two things together, our x coordinate was 0, our y coordinate was negative 1. So this is the vertex. Now y-intercept is going to be the number at the very end, that's c, which they say is negative 1. If you're on the y-axis, so if you're on that line, that means that you have no x-coordinate, because you're just sitting on the y-axis. You didn't go left or right on the x-axis at all. So my c is equal to negative 1. So as a coordinate, we would write that as 0, negative 1. Now for this problem, my vertex and my c are the same point. Do you guys see that? I got 0, negative 1 2 times up there. Because that happens, if I go to graph that one point, I'm only going to have one point. I don't have anything else to graph something else to get my quadratic form. So what I need to do is actually find one more point. So coming down here to the graph, let me just show you what I'm talking about. If you guys graph this down below, if I go to 0, negative 1, that's my vertex. That's also the y-intercept. I have nothing else so far that I can use from what we did up above to graph the rest of this. All I have is a point. So I don't know where it goes. So I need to find another point. So what I'm going to do is just make another XY chart over here. I know 0 was in the middle, so I'm just going to pick a number. You can either go above or below 0. I'm just going to go up to 2. And so if I plug that into my equation, that x squared minus 1, you guys are going to take 2 squared minus 1. What's that going to equal? Good, 3. So this coordinate is, another coordinate is going to be 2, 3. Okay, to graph another point then, remember that there's like an imaginary dotted line that goes down through that vertex. That's that axis of symmetry. How far over is this point from that blue line I just drew? 2. So to reflect it, I go 2 the other direction. So I go to that blue line and I go 2 to the left and I draw another point. You could also plug in negative 2 and you're still going to get 3. So then we've got our quadratic. Let's look at another one together. So I have 2x squared minus 4x plus 5. Is this one, looking at that first term, it's 2x squared. Is it going to open up or open down? Up, because it's positive. It's positive 2. So we're going to say that this opens up again. Okay, so let's work on finding our axis of symmetry. This is when we're going to do negative b over 2a. Looking at your equation, 2x squared minus 4x plus 5. Remember, the 2 is a, negative 4 is b, 5 is going to be your c. If you need to label those points before you get started, I would do that. So we're going to do negative 4. That goes on top because b is negative already. And what's the a term? 2. What happens again when I have a double negative like that on? Becomes positive. So now this is 4 over 4, which is 2. Oh yeah, 1. Thank you. So now we take 1 and we plug it into this function up here. So we're going to take 2 times 1 squared minus 4 times 1 plus 5. So you're going to have 1 squared, which is just 1, times the 2. So 2 minus 4 times 1 is 4, and then plus 5. So what's 2 minus 4 plus 5? 3. So vertex is going to be 1, 3. So can you guys tell me what my C is? 5. So to write that as a y-intercept point, remember I said that y-intercepts you don't have an x because you didn't move left or right. So your x is always going to be 0 for these points. And then your number, in this case, 5. So for this one, my points are different. My vertex was 1, 3. My y-intercept is 0, 5. So I'm going to go ahead and graph both of those points. So starting with my vertex at 1, 3, remember this is where that imaginary line would go in. My vertex is at 0, 5. So where do I want to draw another point at? Across the blue line, right? And I want to do the y-intercept point. So that's 0, 5, that's 1 to the left. So I want to go 1 to the right and draw a new point. All right, so I'm going to give you a couple minutes. I want you to just try to do what you can on this problem. See if you can figure out, like, does it open up, down? If you're not sure, go on to the axis of symmetry. Try to find your vertex. Try to find your y-intercept. So do you guys think that this graph is going to open up or open down? Opens down because it's -3. You all see that? Yes. Okay. So -3 means that it's going to open down. That's going to be like the only difference between what we've been seeing and what we're going to see this time is the graph's going to flip directions. Now, axis of symmetry is going to be your -b over 2a. So the b should be 6, because that's what's in front of your x term. And then a should be that -3. So we're going to have -6 over a -6, which reduces to a +1. That's the x-coordinate of the vertex. So now let's take -1 and we plug it into this function up here. We're going to take -3 times 1 squared plus 6 times 1. So that's going to simplify to -3 plus 6, which would just be 3. So writing the vertex with those 2 points, we're going to get 1, 3. What was your C for this problem? 0. There's no number attached at the end, so it's like, do they add it or subtract a 0? Okay, so the y-intercept is going to be at 0, 0 then, which would be your origin. So again, that's different than my vertex point, so I should be able to graph the entire thing. I shouldn't have to graph like a new point or make a table for a new point. So to graph this one, our vertex is at 1, 3. We've got a point at 0, 0. Remember that imaginary line is going through that vertex point. So we want to reflect 0, 0 over to the other side, so that becomes 2, 0. And then we graph that in. All right, let's look at the next one. We have -2x squared minus 8x minus 14. I'm going to give you a couple minutes. I want you guys to try to do this one as well. All right, does this one open up or open down? Down again, because you've got -2. Negative b over 2a. What'd you guys put in for b? Good. And in for a? So on top we have a double negative, so that's +8 now. And then it's over -4. So we should have gotten -2 for our x. Now we plug this in. So -2 times -2 squared minus 8 times -2 minus 14. That should get you -6 when you type in. If you use a calculator, just type that in exactly how I have it written there. And then your vertex here would be -2, -6. Now the y-intercept then, C is what number? What's the very last number of our equation? -14. So C is going to be that -14. So as a coordinate, that would be 0, -14. So on the graph that you guys have, that point's probably not going to fit very well. So if you wanted to, especially if you're not able to like add space, I mean, you could estimate where you guys think that would be. But when you go to graph it, you could add some extra points to help you graph it a little bit better if you wanted to. So if we graph our vertex first, -2, -6, it's going to open down. So there's an imaginary line going right here. This graph is going to open down like that. If I wanted to, I could just make a little XY chart. You guys could do what we did in section 1. You can put that vertex in the middle, and you could pick a couple points like, we know 0 is at -14, so maybe let's look at what 1 does, -1. -1, if you guys plug it in, you're going to get a -8. That's probably going to be a little bit easier for you guys to graph because it's there. You don't have to worry about estimating anything. So if I go to -1 and go down -8, and then just reflect that over on the left side to get the other point, then I'm able to draw my quadratic graph in. I've got one more that I want us to do together. This one we have 1/3 x squared plus 5. Even though it has a fraction, it changes nothing about this problem, okay? You're going to go ahead and just do this exactly like we did before. You're just going to have to work with that 1/3 a couple of times. So since it says 1/3 x squared plus 5, it's positive, which means it's going to open up. Axis of symmetry, we're going to do -b over 2a. What's the b term for this one? 0. There is no b because there's no x term. And then we would do 2 times 1/3, which we saw this happen earlier. It doesn't matter what happens here because 0 divided by anything is 0. So for my vertex, I'm going to take 1/3 times 0 squared plus 5, which 1/3 times 0 is just going to be 0. So I'm left with just a 5. So my vertex is going to be 0, 5. What's my C, my y-intercept? 5. So what would we write that as a coordinate? 0, 5. Okay, so this is going back to that situation where I have a repeating point, and I need another point in order to help me graph this. Now, when you make your chart to find another point, make it easy on yourself. Okay, so we already know that 0, 5 is a point. Since you have 1/3, put in numbers that you know are going to be easily multiplied to that 1/3. Because if you pick like a 2, 2 squared is 4. 4 times a third is going to be with a fraction. If I put in a 3, what would be 3 squared? 9. What's going to be 9 times a third? 3. Okay, so then we have 3 plus 5, which would be 8. So other solutions there would be just, I mean, you can do fractions, but you'll have to estimate where you think that's on the graph then. Where if I pick a number like that 3, it's going to work nicely with the 1/3 when I go to actually compute with it. All right, now we can graph those 2 points. And then we'll be able to graph a third point using that 3, 8, and we'll reflect it. So vertex is at 0, 5. Remember, there's an imaginary line going through that point, which we'll use to help reflect. So then we go 3, 8. So how far to the left of my green dotted line should I go for my other point? How many spaces over? How far away is 3? So I go to the left 1, 2, 3. And drop it. Now this graph's going to be a little bit wider than the ones that we've seen before. And if you remember when we talked about transformations, things like 1/3, 1/2 are going to make those graphs become compressed. So they're going to squish them down, but they're going to become really, really wide. So that's normal for that to happen when we have a fraction like that in the front.